So welcome everyone. In this video lecture, we will study about graphical representation of motion. Okay, and then we will see how we can describe a motion in terms of graphs. And then one of the good things about graphs is you can look at one plot and then it will tell you exactly all the details of that particular motion. Okay. Specifically in this lecture we will talk about two types of graphs. One is a distance time graph and another is velocity time graph, and both have their own applications and characteristics. So we will learn in detail about each of these type of graphs. Okay, so if I want to draw a distance time graph, in a distance time graph your time is on the x-axis and your distance is on the y-axis. Okay, and then you plot based on where the motion is and then you plot the points as along your motion. So let's take an example here. I have a person, it is at point A, then it goes to point B, and it goes to point C. Okay, so A is basically origin, so it was 0 second and 0 meter. Point B is basically 1 second and it reaches a distance of 10 meter, and point C is 2 seconds and then he reaches, let's say, a distance of 15 meter. Okay, so if I want to draw this here, so point A was here, which is 0, 0, right? And point B is somewhere here, which is basically 1, 10, which is 1 second and 10 meter, right? Generally you denote the unit in the axis itself, so let's say distance is in meter and time is in seconds, so you don't have to keep writing that. And then point C is basically, let's say here, which is basically 2 seconds and 15 meter, right? So all I have to do now is join the points, which is A to B and then B to C. Okay, so now I know exactly how the motion is happening without even looking at the picture, because I know the person was at time equal to 0, person was at a point A and then B and then C. So that's a beauty of the distance time graph, because it gives the details of the motion in one snapshot. Now there are other characteristics of a distance time graph. Let's learn those. In the previous lectures we have studied about uniform motion, right? So in a uniform motion definition is speed is constant, right? Speed is constant. So object changes equal distances and equal intervals of time. So if I want to plot an example of uniform motion in a distance time graph, how will that be? So that's the question, right? So consider an example. So basically, let's say we have a person, okay, and then he's at point A, which is 0 second and then 0 meter, so this is my origin. Then it moves to point B, which is, let's say, 1 second and 10 meter, and then so in 1 second the object covered 10 meter, right? So if it is uniform motion, if point C, if there is another second, so it is 2 seconds, so object will cover same distance as it covers in the first second, right? So that would be another 10 plus 10, so it would be 20 meter. Okay, so if I want to plot this on a graph, so the graph we are plotting is distance time graph, right? So this is time and this is distance, and the distance is basically in meter and time I'm measuring is in seconds. So object is at point A, which is 0, 0 seconds and 0 meter, and then object moves to point B, which is 1 second and then 10 meter, and then object move to point C, right, which is basically 2 seconds and 20 meter. So the distance time graph of a object moving in uniform motion is basically a straight line. So I did not do a good job here. So it's going to be the points A, B, and C. So as the object is moving in a straight line, it's covering an equal distance in equal intervals of time, and that's a characteristic of a uniform motion too. It's like, and we talked about that in the lecture too, that if you plot a uniform motion in a distance time graph, that would be a straight line. Another way to look at it is if you look at the slope of this graph, which is 10 theta, right? So basically slope of this graph is a speed. And if I want to draw a slope of this graph, let's say a few more things, it is d, right? So slope of this graph would be between A to B is so slope of this graph would be BD by AD, right? So, and that would be, so slope, right? This is a slope would be BD by AD. So and that would be what? So BD is a distance, right? So it would be 10 meter here, and then AD is 1. It's 1 second, so that is 10 meter per second. So the slope of the graph is basically your speed. Now in a uniform motion, speed is constant, right? So as we have seen before, in a uniform motion, speed is constant. So if we relate these two, in a uniform motion, the distance time graph will have constant slope. So slope of this graph would be constant throughout the journey. That means speed is constant, and if the slope is constant, that would be a straight line. So means one thing we have learned in this distance time graph is for uniform motion, distance time graph has a straight line, and then you can calculate the speed by the slope of the distance time graph. So if questions are given you in terms of graphs and they ask you calculate the speed, you just take the slope of that graph, and that will give you the speed of that graph at that motion. Okay. So far we have studied about distance time graph in a uniform motion. So what happens in a non-uniform motion? So if I am looking at non-uniform motion, okay, so if I'm looking at non-uniform motion, then my distance time graph will not be straight line. So this is time and this is a distance. So if I'm looking at non-uniform motion, then my distance time graph will not be straight line, would be a curve. Okay, so and these are the two things about the distance time graph. One is in uniform motion you have a straight line, and in a non-uniform motion you have a curved line in distance time graph, and then the slope of the graphs gives you the speed at that point. So next we will study about velocity time graph. So in a velocity time graph, your time is on the x-axis and your velocity is on the y-axis, right? So if you consider an example where a car is moving with some velocity, let's say v, and then its velocity is changing. Let's say it was v0 before and v1 after time t1, v2 after time t2, and all that. So you will draw all those points here. Okay, so you'll look at point A, which is v1 and then t1, right? So you draw all those points and connect all that points, and that will give you your velocity. So connecting all these points, it will give you a velocity time graph. Okay, now there are a couple of very important characteristics about the velocity time graph, so let's understand that. The first one is basically in a velocity time graph, your slope of the graph gives you an acceleration. So if I have a velocity time graph, let's say it's a straight line, so this is my velocity and this is my time. So if the motion is a straight line, so if I am looking at the slope of that motion at any point, let's say looking at the slope at the point A. So the slope of that graph gives me an acceleration. So acceleration is basically slope of velocity time graph. Okay, so so if you are presented a graph of velocity and time, and question is asking you calculate the acceleration, so just look at the slope of that graph, and then you can easily calculate the acceleration of that motion. So now a couple of things about that. It's like in a velocity time graph, okay, so if I look at velocity time graph, let's say example of a car, right, and it's moving forward. So and if the car is moving with uniform acceleration, we talked about that in the previous lecture. If a car is moving with uniform acceleration, so let's say acceleration is uniform. What does that mean? Uniform acceleration means constant acceleration, right? So acceleration is not changing, constant acceleration. Okay, so if the acceleration is not changing, so if I'm drawing the velocity time graph, my slope is not changing, right? So slope is basically my acceleration, as we have seen. So any point theta 2, theta 1, so if any point, let's say point A here, point B here, my slope is constant. So slope at A is equal to slope at B. Okay, so slope is not changing, and only way that can happen if this is a straight line. Okay, so if the motion is a straight line, your slope will be constant. So for uniform acceleration, your velocity time graph has a constant slope. So constant slope is there for a velocity time graph in a uniform acceleration. So remember that if I'm looking at uniform acceleration, my slope of the velocity time graph would be constant. So what would be opposite of that? So if let's say my question is given me this velocity time graph, so this is time and this is velocity, and motion is like this. Okay, so now if the question is asking if this is a example of a uniform motion or not, uniform acceleration or not, and the answer would be not, because since this acceleration is basically your slope, right? So if I'm using a green one here, so theta here and then theta here, right? So at all these points A, B, and C, my slope is changing. So my slope is changing, that means my acceleration is changing. If the acceleration is changing, then the motion is not uniform acceleration, because uniform acceleration means constant acceleration. So remember that in a uniform acceleration, slope is constant, so straight line. In a non-uniform acceleration, the slope is varying, so it's the graph would be curvature, has some, it would be curved line. Another very important property of a velocity time graph is it can tell you displacement too. So if I'm looking at the velocity time graph, so the area under velocity time graph gives you magnitude of displacement, right? Displacement is a vector quantity, so it has both magnitude and direction, and area is always scalar quantity. Area does not have magnitude, so the area under velocity time graph is equal to magnitude of displacement. So what I mean by that, so if I'm drawing a velocity time graph, so this is my time, this is velocity, and my object is moving from, let's say, point A to point B, right? So if I want to calculate the displacement of that object, so only thing I know is the velocity of that object at point A, which is v1, and then time is t1, and point B, the object has velocity v2 and then time is t2, and question is asking me what is the area of that, not what is the displacement of that object as it goes from A to B. I can easily calculate that, right, by looking at this area. So if I just draw this, complete this triangle, so this all this area, once I calculate the area, I can calculate the displacement of that object. Okay, so just keep in mind, area under the velocity time graph gives you the displacement. So let's consider an example here. Imagine we have a car. Okay, so we have a car here. It was at velocity, let's say 5 meters per second, and then initially, let's say this is my reference point, so it was 0 second is the time when I was looking at this motion. So point A, it goes from point B and then point C. So at point B, let's say it has traveled 1 second and velocity is now 10 meters per second. And once at point C, it has traveled 2 seconds, velocity is now, let's say, 15 meters per second. Okay, so now I'm drawing a velocity time graph. So would be, right, so this is my time in seconds and this is my velocity in meter per second, right? So initially at time equal to 0, car is at point A, so which is would be here, right? Because car is at 0 time and then 5 meter per second velocity. It goes from point A to point B, which is basically 1 second and then 10 meter per second. Then it goes from B to C, which is basically 2 seconds and 15 meter per second, right? So if I'm connecting all this, okay, so remember we're connecting these dots in a velocity time graph. Now let's say the question is asking calculate the displacement of this car between A to B. So I need to calculate this displacement, right? So how do I calculate that? It's pretty easy. So I connect this. So all I have to do is calculate the area of this velocity time graph under time axis, right? So if I so basically between A to B, I need to calculate this area. Okay, so once I know this area, I can calculate the displacement of this car between A to B. Okay, and what is the area under in this one? Let's add me few more points. So let's say this is D and this is E. Okay, so area would be basically, let me use a white color here. So area would be area of A, B, E, D. Okay, and this was C, just we don't forget it. So area would be basically your magnitude of displacement. Okay, and that would be displacement of the car between A to B as it goes from A to B. Similarly, if the question is asking you what is the displacement of this object as it goes from B to C, all you have to do is connect this point, B and C on the time axis, and all of this area, right, would be your displacement of the car as it goes from B to C. So it's pretty simple, as you can see. Just by looking at the graph and calculating the area, we can easily calculate the displacement of this object. So remember a couple of things we have learned. If the velocity time graph is showing a straight line, then your motion is a uniform motion, right? And if the velocity time graph is showing you a curvature where the curve like the graph is not a straight line, then you have a non-uniform motion. Okay, and you can calculate the displacement of a motion by looking at the area under velocity time graph. So 3 points. Okay.